Welcome back, everybody. We are jumping ahead now to lesson 13 of Unit 7. In this particular lesson, we're going to talk about experiments, more about experiments. We already know what an experiment is, but we know that an experiment is the only way we can actually prove or disprove a cause and effect relationship. And as it says here, an experiment provides a way for us to assess the effect of certain conditions on a response variable. So a typical experiment that you might see is to test the effectiveness of a medicine. In medical trials, they'll conduct experiments with different people participating, and the data that they provide allows them to assess the effectiveness of that medicine. Okay. The name of the game with experiments, as it says here, is randomness. When you conduct experiments, it usually involves groups. And in this case, you want to separate the subjects or the participants into groups randomly. Okay. Randomly is really important because you want to prevent biased results, and you want to particularly prevent other possible sources from affecting those results. The groups that you divide people in are called the treatment groups. So, for example, in a medical trial, one group might receive the actual medicine, and the other group might receive what they call a placebo, which is essentially a fake medicine. So they can actually compare the people that didn't take the medicine with the people that did take the medicine, and that allows them to assess the effectiveness of it. There was another example in a stats textbook that I've used before, where they were testing the effectiveness of an energy drink, and they divided the participants into two groups randomly, and one group uh, was given the actual energy drink, and the other group was given a placebo. And the placebo was a fake energy drink. It tasted like the energy drink, it looked like the energy drink. For all intensive purposes, they thought it was the energy drink, but it really wasn't. But by doing that, it allowed them to compare the results of the two groups and really tell whether the energy drink is effective or not. Once you do that and you collect your data, you can do a randomization distribution. And we've seen examples of that before. A randomization distribution is a distribution of the differences between the means for treatment groups containing randomly redistributed data. Sometimes it might turn out to be a normal distribution, a bell curve, and sometimes it might not be. But that randomization distribution would allow us to make a conclusion, if we can make any conclusions based on the experiment. So, with that in mind, let's go ahead and go to the examples here. I am going to actually answer most of these questions verbally, so you want to make sure you pay attention as I'm going through these. So, does counting while exercising affect your heart rate? Let's think about how to design an experiment. For another lesson, the class will be divided into two groups. One group will do an exercise silently. So that's one group. Okay. The other group will count out loud while they do the exercise. Which of these methods would be good for dividing the class so that the results are based only on the counting and heart rate rather than other factors? Explain your reasoning for each method suggested. So we are looking for which one would be the best. So the athletes in the class are assigned to the counting group, and the non-athletes are assigned to the silent group. The teacher puts everyone's name in a bag and draws half of the names. The names that are drawn are in the group that counts, the others remain silent for the exercise. The tallest half of the students are put in the counting group, and the shortest half of the students are assigned to the silent group. So there's three possibilities here. Which one of these is the most random? Okay. Which one of these is least likely to lead to biased results? Well, by putting names in a bag and drawing at random, that by definition is a random sample. So that right there, B, would be the best because it is the most random of all the methods. If you put all the athletes in one group and all the non-athletes in another group, that might skew the results, lead to biased results. Same with putting all the tall people in one group and all the short people in another group. That's not really random. Same thing with athletes and non-athletes. The only one that's truly random is if you put everyone's name in a bag and pick it without actually looking. So B would be the best. That would be which of these methods would be good for dividing the class so that the results are based only on counting and heart rate rather than other factors. The answer is B. Okay. Do you think counting out loud will have an effect on heart rate? That's an opinion-based question. So for number 2, there really isn't a right or wrong answer. For me personally, I would probably say that no, it probably won't have a really large effect on heart rate. It might have a very small effect. It might be slightly higher or slightly lower, but not very significant effect. So that would be my opinion for number 2. Your opinion may be different. You may be different. Really, the name of the game is how you explain why you feel one way or the other. So that's number 2. A treatment is the value of the variable that is changed between the two groups in an experiment. So what is the treatment in this experiment? In other words, what are they testing out? Obviously, they're not testing a medicine or they're not testing an energy drink. They're testing how they do exercise. So there are 2 treatment groups. The first treatment group is counting out loud. So the first group will count out loud while they exercise, and the second group is silent. So they'll do their exercises and they won't say anything. Okay? Those are what we call the 2 treatment groups for number 3. Okay? Number 4, how would you design an experiment to answer the question, does counting while exercising affect your heart rate? So again, I'm going to answer this verbally. So if I were going to do my own experiment with a class of mine, to answer that question, how would I set up the experiment? Well, the first thing I would do is I would divide the class randomly into 2 groups. And I would use the method described up here. I'd put everyone's name on a piece of paper. I'd put it in a hat or a bag. And I'd keep picking names out of the bag or out of the hat until I have half the names. And the half of the names that I pick will be in the counting out loud group. And then the names that I don't pick, the names that are remaining, will be in the silent group while exercising. Okay, so that is how I would set up the experiment. I would imagine a lot of you would probably set it up the same way, but that is what they mean by how would you design or how would you set up the experiment. In other words, how would you divide your participants into groups? Okay, and that is how to set up an experiment. Again, the key part of this lesson is that randomization is the name of the game. The more random things are, the more useful the results are going to be. So that is it for this particular lesson.